Welcome back. We're going to do homework for section 5.4 on scientific notation. Okay, number 1, explain how you would write the number 0.00000000062 in scientific notation. Part 1 says to move the decimal point between the blank and blank. Okay, you always want a digit between 1 and 9 to the left of the decimal point. So I would move the decimal points between the 6 and the 2. And then you're going to multiply by 10 to the blank. Okay, here we go. I'm going to count the number of spaces. It would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I would have to move that decimal place point 10 places to the left. So it would be to the negative 10 power. Okay, so part 2, I'm going to write it as 6.2 times 10 to the negative 10. Number 2, here's another really small number, and I need to write it in scientific notation. So I would put the decimal point between the 3 and the 8, so it's going to be 3.8 times 10. Okay, I need to move the decimal point to get back to the real number to the left, so it's going to be to the negative something. So how many places are we going over? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I need to multiply by 10 to the negative 24. Question 3. The human heart pumps about 2,100 gallons of blood per day. That means it pumps approximately 767,000 gallons per year. So I want to write the number in scientific notation. I would want to put the decimal place between the 2 and the 1. So it would be 2.1 times 10 to a power. This time I need to move the decimal to the right. 1, 2, 3 times, so it's going to be times 10 to the third. The second number, 767,000 gallons. Okay, where's the decimal point going to go? It's going to go right here between the 7 and the 6, so 7.67 times 10 to the, okay, again we're going to move to the right. 1, 2, 3, 4, 5 decimal places. So I get 7.67 times 10 to the 5th. Question 4. Write the number in standard form. So they give it to you in scientific notation. They ask you to write it in standard form. So 7037. Okay, in scientific notation, the decimal point is here. But it says to do times 10 to the third. Okay, this is a positive number, so it means I'm going to move the decimal to the right. And I need to move it to the right 3 places. 1, 2, 3. My decimal point will now be right there. So my number becomes 7037. Since there's no numbers to the right of the decimal place, I can put it there, but I don't need to, and my math lab will probably count it wrong if you do. So the number is 7,037. Question 5, write the number in standard form. So here we go, 393,701. All right, this time I'm multiplying by 10 to the negative 8. So negative number, I'm going to move the decimal place to the left. So it was here in the scientific scientific notation, I need to move it 8 places to the left. 1, 2, 3, 4, 5, 6, 7, 8. So my decimal point is going to go right here. Now look at all those places that don't have digits. You're going to put zeros in all of those. So how many zeros did I just write down? 1, 2, 3, 4, 5, 6, 7. So I need to write 1, 2, 3, 4, 5, 6, 7 zeros. And then the digits 3, 9, 3, 7, 0, 1. Now, it's usually standard form to put a 0 in the front as well. You do not have to, but Connect Math may tell you the equivalent answer has the 0 up front. Question 6 asks you to multiply two numbers that are given to you in scientific notation. 2.5 times 10 to the 9th times 2.6 times 10 to the negative 4. All right, I'm going to regroup. Since this is multiplying everything, right, I'm going to write that as 2.5 times 2.6, and then times 10 to the 9th times 10 to the negative 4. And the reason I'm doing that, we have rules of exponents. When you're multiplying like bases, 10 to the 9 times 10 to the negative 4, you can add those exponents. What's 9 plus negative 4? That's going to be 10 to the 5th. Okay, now I need to go do the digits. You can go to the side and do that by pencil and paper, or use your calculator. What is 2.5 times 2.6? It's 6.5. So my answer would be 6.5 times 10 to the 5th. 6.5 times 10 to the 5th. Question 7. Let's go multiply two numbers that are given to you in scientific notation. 5.3 times 10 to the 10th times 6.8 times 10 to the 3rd. So I'm going to multiply 5.3 times 6.8, and then I have times 10 to the 10th times 10 to the 3rd. Okay, when I multiply 10 to the 10th times 10 to the 3rd, I get 10 to the 10 plus 3, which is 10 to the 13th. Now for the number part, 5.3 times 6.8. 5.3 times 6.8, it's 36.04. Uh-oh. Okay, this is not in scientific notation anymore, because the number to the left of the decimal point can only be a digit between 1 and 9. I'm going to write that number that's there in purple as 3.604 times 10 to the, what would that be? I need to move, if it's 36.04 and I put the decimal point here, I need to move it one place to the right. So that would be times 10 to the 1. 3.604 times 10 to the 1 is the same as 36.04. All right, so here's what I have right now. Uh-oh. You see that I have 2 times 10 to this? 10 to the 1 times 10 to the 13 is 10 to the 1 plus 13. And I still have the 3.604. So my final answer would be 3.604 times 10 to the 14th. All right, calculator time. Let's back up and do this one on the calculator. Okay. 2.5 times 10 to the ninth. 2.5 times 10 to the ninth times 2.6 times 10 to the negative fourth. 2.6 times 10 to the negative 4. Nope. There we go. Okay. 6500000. So if I put this decimal point between the 6 and the 5, I would need to say times 10 to the 1, 2, 3, 4, 5. Now, your calculator also has a mode. So if you hit the mode button next to the second button, down here it says normal versus scientific notation. So normal is the same as standard. And then we have scientific. So I'm going to arrow to the right and hit enter. And then second quit. Okay, if I go up and type this in again, watch what happens. It gives it to me in scientific notation now. 6.5 E5. That E5 means times 10 to the fifth. So here's another quick tidbit. If you didn't want to say times 10 to the ninth, watch this. 2.5. See the EE above the comma that's above the 7? It's in blue, so I'm going to hit second and then the EE. That means 2.5 times 10 to the ninth, and then times 2.6 times 10 to the negative 4. And it gives it to you. Okay, I'm going to go turn my mode back to normal. And then I'm going to do the second problem. Okay, we want to write 5.3 times 10 to the 10th. Here we go. 5.3 times 10 to the 10th times 6.8 times 10 to the third. 6.8 times 10 to the third. And it automatically gives you back to you in scientific notation. 3.604 times 10 to the 14th. 3.604 times 10 to the 14th. Okay, question number 8. We're going to do it by hand, and we're going to confirm the answer with our calculator. 7 times 10 to the negative 4 divided by 5 times 10 to the ninth. Just like with multiplication, I'm going to do the number part first, 7.0 divided by 5.0, times 10 to the negative 4 over 10 to the 9. Now, on the right, when you are dividing like basis, you can say that that's 10 to the negative 4 minus 9, which would be 10 to the negative 13. Now for the number part. 7.0 divided by 5.0 is 1.4. So I get, and that's in the right form, 1.4 times 10 to the negative 13th. That's my answer. Now if I want to do this directly on the calculator, I'm going to say here comes a fraction, alpha y equals number 1. My fraction is 7.0 times 10 to the, was it negative 4? Yeah, negative 4 over 5.0 times 10 to the ninth. 1.4 times 10 to the negative 13th. 1.4 times 10 to the negative 13th. All right, number 9. We're going to do the number part first, 1.98 divided by 9.9. Then we're going to multiply by 10 to the negative 7 over 10 to the negative 9. So the number part first. What is 1.98 divided by 9.9? I get 0.2. So this is 0.2. This part is 10 to the negative 7 minus negative 9, which is 10 to the negative 7 plus 9, so 10 to the second. Now, the pink part is not written in scientific notation. To write it in scientific notation, that would be 2.0 times 10 to the negative 1, because I need to move it over 1. And then combining the powers of 10 again, that would be 10 to the negative 1 plus 2, which is 10 to the 1. So I have 2.0 times 10 to the 1. Now, most of you are saying, I don't like doing anything by hand. Show me how to do it on the calculator. So here comes. Here comes a fraction. I'm going to do alpha, y equals, and number 1. Okay, the fraction in the numerator is 1.98 times 10 to the negative 7. 1.98 times 10 to the negative 7. In the denominator, I have 9.9 times 10 to the negative 9. 9.9 times 10 to the negative 9. Is that right? Yes. My answer is 20. That doesn't give it to you in scientific notation. You've got to know that the number 20 is written as 2.0 times 10 to the 1. Number 10. At one time, Bill Gates owned approximately, 1,200,000,000 shares of Microsoft stock. If the stock price was $29 per share, how much was Bill Gates' stock worth? So each share was worth $29. I had 1.2 billion shares. So I need to multiply 1.2 billion times $29. Okay, 1.2 billion is 1.2 times 10 to the, 1, 2, 3, 4, 5, 6, 7, 8, 9. So times 10 to the 9. I want to multiply that by 29. Let's go do the numbers first. What is 1.2 times 29? And then I also have times 10 to the 9th. Okay, 1.2 times 29. 1.2 times 29 is 34.8. 34.8 times 10 to the 9th. But 34.8 is not in scientific notation. So I need to write 34.8 as 3.48 times 10 to the, and I need to move it over one place, so times 10 to the 1, times 10 to the 9. 10 to the 1 times 10 to the 9 is 10 to the 10th. So my final answer is 3.48 times 10 to the 10th. Okay, had I done this on the calculator to begin with, I would want 1,200 times $29 per share. I get 3.48 times 10 to the 10th. 3.48 times 10 to the 10th, right there. Last question, number 11. Dinosaurs became extinct about 65 million years ago. Write the number 65 million in scientific notation. Okay, here we go. 65 million. There's 65 million written in standard form. To write it in scientific notation, I would want to write 6.5 times 10 to the 1, 2, 3, 4, 5, 6, 7. So in scientific notation, part 1, 65 million is, what did I say, 6.5 times 10 to the 7th? Okay, 65 million years is how many days? Okay, to get the number of days, we have 6.5 times 10 to the 7th. That's how many years, and each year has 365 days. So I'm going to multiply the 6.5 times 365, and then I've got to multiply that by 10 to the 7th. All right, 6.5 times 365 is 2372.5. 2372.5 times 10 to the 7th. But I don't like how this is written in standard form. I need to convert it to scientific notation, so that's going to be 2.3725 times 10 to the, I need to move it 1, 2, 3 places to the right, and then I still have times 10 to the 7th. So my final answer is 2.3725 times 10 to the 3 plus 7 is 10. That's how many days ago. Okay, I could have done 6.5 times 10 to the 7th times 365 on my calculator. 6.5 times 10 to the 7th, and then times 365. 2.3725 times 10 to the 10th. Is that what we got? Yes. Okay, part 3. 65 million years is how many hours? So if we know it's this many days, how many hours are in one day? We're going to do this many hours, and each day, that's how many days, each day has 24 hours. So we're going to multiply that number by 24. So here goes, 2.3725 times 10 to the 10th times 24. 5.694 times 10 to the 11th. 5.694 times 10 to the 11th. Yep. Okay. Then it's asking 65 million years is how many seconds? So there are this many hours, and each hour, here we go, this many hours, and each hour has 60 minutes, and each minute has 60 seconds. So our final answer will be 5.694 times 10 to the 11th times 60 times 60. 2.04984. 2.04984 times 10 to the 15th. The dinosaurs became extinct this many seconds ago.